Reciprocal identity. Sin x is equal to 1 over cosecant x. Cosine x is equal to 1 over secant x. Tangent x is equal to 1 over the tangent x. Ratio identity. Tangent x is equal to sin x over cosine x. Cotangent x is equal to cosine x over sin x. Pythagorean identity. Sin squared x minus 1 is equal to cosine squared x. Tangent squared x plus 1 is equal to secant squared x. Cotangent squared x plus 1 is equal to cosecant squared x, which is also equal to sin squared x minus 1 is equal to cosine squared x. Secant squared x minus 1 is equal to tangent squared x. Cosecant squared x minus 1 is equal to cotangent squared x. R given is sin squared x plus 2 cosine x minus 1 over sin squared x plus 3 cosine x minus 3 is equal to 1 over 1 minus secant x. Let's start by changing sin squared x to 1 minus cosine squared x in the numerator and denominator. It was derived from the Pythagorean identity. We will combine like terms, so negative cosine squared x plus 2 cosine x will remain in the numerator, and negative cosine squared x plus 3 cosine x minus 2 as the denominator. We will extract the negative signs since cosine squared x will change its signs. The whole equations will change its sign. We will factor out the numerator using the common monomial factoring. Since we have the same terms in the numerator and denominator, we will do cross cancellation. Cosine x over cosine x minus 1 will remain. The numerator is cosine x. By the equation, cosine x over cosine x is equal to 1. 1 over 1 minus 1 over cosine x using the reciprocal identity. Our equation is now 1 over 1 minus secant x is equal to 1 over 1 minus secant x.
In all equations, you have to choose the more complex row because it will be efficient. And so in problem number 2, we will choose the left-hand side of the equation. Using the reciprocal identity, in cosecant x, we will get 1 over sin x. And in cotangent x and tangent x, we will use ratio identity. Cotangent x is cosine x over sin x, and sin x over cosine x 4 times. We factor out sin x in the denominator, so it will be sin x times 1 plus cosine x over cosine x. Our equation now is 1 plus cosine x over sin x times 1 plus cosine x over cosine x. We divide it. 1 plus cosine x over sin x times cosine x over sin x times 1 plus cosine x. We will reciprocal the denominator since it is division. 1 plus cosine x will be cancelled out. Cosine x over sin squared x will remain, and we break sin squared x into 2. Cosine x over sin x and 1 over sin x. The ratio identity of 1 over sin x is cosecant x, and the reciprocal identity of cosine x over sin x is cotangent x. Now we prove that cosecant x plus cotangent x over tangent x plus sin x is equal to cotangent x cosecant x. The given is secant x plus cosecant x over tangent x plus cotangent x equals sin x cosine x. We will verify the left side. Using the reciprocal identity on the numerator, secant x is 1 over cosine x and cosecant x is 1 over sin x. On the other hand, we will use ratio identity on the denominator. Tangent x is sin x times cosine x and cotangent x is cosine cosine x, sine x. Since we simplified the equation, we will divide the numerator and denominator. In dividing, we will reciprocal the denominator. Sine x plus cosine x over cosine x sine x multiplied by cosine x sine x over sine squared x plus cosine x sine x will be cross cancelled, so our equation now is sine x plus cosine x over sine squared x plus cosine squared x. We will now use Pythagorean identity on the denominator. Sine squared x plus cosine squared x is 1. Sine x plus cosine x over 1 is sine x plus cosine x. And method on the left side. 1 plus sine x times 1 minus sine x minus 1 minus sine x times 1 minus sine x over 1 minus sine x times 1 plus sine x. The product of 1 plus sine x times 1 plus sine x is 1 plus 2 sine x plus sine x squared x. Product of 1 minus sine x times 1 minus sine x is 1 minus 2 sine x minus sine squared x minus sine x minus sine squared x. We will distribute negative in 1 plus 2 sine x minus sine squared x, so it will be negative 1 plus 2 sine x minus sine squared x. We now simplify the equation. 4 sine x over 1 minus sine squared x. We will use Pythagorean identity on the denominator. We will get 4 sine x over cosine squared x. We will break cosine squared x into 2. So it will be 4 sine x over cosine x times 1 over cosine x. Using the reciprocal identity, the answer will be 4 tangent x secant x. We will use the left side. Tangent cube x plus cotangent x. Breaking it down, it will be tangent x plus cotangent x times tangent squared x minus tangent x cotangent x plus cotangent squared x. Using the formula a plus b times a squared minus ab plus b squared. We will simplify tangent squared x minus tangent x cotangent x plus cotangent square x. Using the Pythagorean identity in tangent squared x, we will get secant squared x minus 1. Similar to tangent squared x, we will also do the same with cotangent squared x. We will get cosecant squared x minus 1. Using the ratio identity in tangent x, we will get sine x over cosine x, and on cotangent x, we will get cosine x over sine x. We will now distribute negative, so it will be secant squared x minus 1 plus cosecant squared x minus 1. We now combine like terms. The answer will be secant squared x plus cosecant squared x minus 2. Tangent x plus cotangent x times secant squared x plus cosecant squared x minus 3 is the final answer.
That's all. Thank you for watching.